Am I audible now? Hi, my name is David Jeffers. I am a Principal Site Reliability Engineer at the American Registry for Internet Numbers, or ARIN. Am I switching? There. ARIN is a nonprofit that's responsible for administering internet numbers across North America, including parts of the Caribbean. When I explain what I do to family members or friends that aren't in the industry, I might say something like, we're a phone book for IP addresses, but there's a lot more to it than that. We offer routing security, we offer reverse DNS, and we participate in a lot of community outreach, including things like evangelizing IPv6 adoption and RPKI. The database that's core to our infrastructure is known as John Pastell's Notebook. It stores all of our customer data, the organizations those customers might be a part of, and the number of resources, how those are actually assigned to those organizations. The John Pastell's Notebook started as an actual notebook and grew into more notebooks after John Pastell was tired of writing them through the one specific notebook, and the ARPANET just filled it all the way up. And once too many notebooks became a problem, moved to a database, and after that initial database, I made a couple more migrations and finally ended on Postgres, which is where it remains today. That is one of those notebooks. You heard earlier in the keynote that a nonprofit often has to do some outsized work with a lot less. Open source is an excellent tool for that, and Postgres really is an established, reliable database software that embodies that. So that was a clear choice to us when we made that migration a number of years ago, and it's been great for us since. Prior to the modernization efforts, JPN was hosted on a physical cluster. So all of the clustering was reliant on physical hardware, whether that was cables and SNMP queries to do some sort of fencing operation if a Postgres node was down. And that proved difficult to create more clusters, and especially in like local testing environments. And with less testing means the brittle updates, and meant that didn't really scale well. So that meant also a lot of the knowledge was limited to a subset of individuals at the organization. So while it was rock solid for us for a number of years, we knew that when we were making a major version upgrade to Postgres that we wanted to change the clustering software as well. We had some specifications that we had to hit. We wanted to remain on-premise, we wanted to stick with something open source, and we wanted something that offered IPv6 support. And there's a clear clustering open source software that you guys might be able to think of, Kubernetes. So we as an organization were really exposed to it first in 2018 when few members of our engineering department attended DevOps Days DC. And we really liked all the blue-green deployments and the lack of Saturday deployments that people were talking about there. So we're like, well, let's go that direction. We migrated a few smaller applications to Kubernetes, and we began to not really keep the inertia behind that. So we had a lot of stuff still hosted in sort of a legacy pattern. I decided to do something a little bit unorthodox and start with our stateful workload, the production database. And since March of this year, JPN has been hosted on Kubernetes. So we have API-driven Postgres clusters with cloud-native open source at its core. That has a lot of high availability to it. So there's both HA within the multiple clusters. We've got the built-in features from Kubernetes like anti-affinity to keep pods spread across the different nodes. We've got Postgres native features like synchronous replicas to ensure that the data is actually written and stored safely and durably. And all of this is provided through a Postgres operator that's just hosted on Crunchy Data. That's hosted on Kubernetes. We use the Crunchy Data operator. There's a couple other offerings out there like Cloud Native PG. I think Percona mentioned one earlier. If you make a migration of your database to Kubernetes, I highly urge you, just like they mentioned earlier, use an operator. It is just vital in making it manageable. We had some major wins as part of this migration. The operator makes the backups greatly simplified, which means that we can restore the backups more often in sort of test environments, which means that we're actually testing our backups. And it's kind of, if you're taking backups and they aren't being tested, you actually have backups. We've got better monitoring in place. And alongside this parallel, we were doing a migration to Prometheus from the more old school Nagios style monitoring. So we have a bunch of stuff already on Prometheus, and now the database is on that as well. And we're able to spin up local testing environment clusters that look just like production. They use the same software, so the same sort of tooling set that triggers a changeover from primary to a standby is the same in production as it is just on someone's laptop. That allows for zero downtime upgrades for minor version updates. So if you're looking to migrate your workloads, maybe start with a database. Thanks.
Thank you so much.